In this video, we're going to have a look at combined questions on surface area and volume. Example 1. The measurements of cylinder A are doubled to form a new bigger cylinder B. Question A. Determine the ratio of the surface area of cylinder A to that of cylinder B. The formula for total surface area will be 2 areas of a circle, and for the smaller cylinder, the radius of the circle is 3, and then we add to that the circumference of the circle, which we multiply with the height of 7. And now we need to repeat this for the bigger cylinder. The bigger cylinder now has a radius of 6, and its height has also doubled and will now be 14. Both these surface areas will be decimal answers. So when you need to compare them, it is easier to keep them in terms of pi. The smaller cylinder has a surface area of 60 pi, and the bigger surface area will be 240 pi. And now we can easily simplify because pi divided by pi is 1. So simplified, this is a ratio of 1/4. In the chapter on measurement of two-dimensional shapes, we already saw that when all the measurements of a shape are doubled, the area of the shape will become 2 to the power of 2 times bigger, and therefore 4 times bigger. And here we just saw that the total surface area of cylinder B is 4 times bigger than that of A. Question B. Determine the ratio of the volume of cylinder A to that of cylinder B. To calculate the volume of a cylinder, you calculate the area of the circle, and we start with the smaller one with a radius of 3, and multiply that by the height of the shape. Repeating that for the bigger cylinder, we now have a radius of 6, and the height has changed to 14. Again, I'm going to write down the volumes in terms of pi. The volume of the smaller cylinder A is 63 times pi, and the bigger cylinder will be 504 pi. And simplified, this is a ratio of 1/8. So the volume of the bigger cylinder is 8 times bigger than that of the small cylinder. The reason for this is that volume is measured in units to the power of 3. So when all the units are doubled, it is 2 to the power of 3, and that is 8 times bigger. Question C. If the measurements of cylinder B now also double to form a new bigger cylinder C, give the volume of cylinder C. We know that the volume of cylinder B is 504 pi. And we just saw that if all the measurements of a cylinder are doubled, the volume will become 8 times bigger. So the volume of cylinder C will be 4032 times pi, and rounded to 2 decimals, that will be 12,666,9 meters cubed. Example 2. The volume of a triangular prism is 160 centimeters cubed. If the height of the prism is 10 centimeters, calculate the area of the base. Usually, we calculate the area of the base and then multiply that with the distance between the two identical sides, or the height, to calculate the volume. But this time, the volume was given in the information. This time, the area of the base is left out, which means that is what we now need to determine. So now I'm still going to substitute into my formula, but now we know that on the left-hand side, the volume is 160. We need to calculate the area of the base, and that value should be multiplied with the height, which is given as 10. Now, to solve this area of the base, we need to divide both sides of the equation by 10. So on the left, we'll be left with 16. Remember that this is an area, and therefore the unit will be centimeters squared. Example 3. The volume of a cylinder is 96 pi cubic centimeters. If the height is 6 centimeters, calculate the radius. So here once again, the left-hand side of the equation is given as a volume of 96 pi. So when we substitute, we know the left-hand side, and on the right we have pi times the radius squared, which we need to calculate, times by the height, which is given as 6. So to solve r, my next step will be to divide both sides by pi and 6. On both sides, the pi's will then cancel, and on the right we'll be left only with r squared. On the left, we will have 16. And to finally get the value of the radius, I need to take the square root of 16, so the radius will be 4 centimeters.